Number 18, your school sailing club wants to buy a sailboat. The table shows the lengths and costs of the sailboat. So a boat that's 11 feet long is going to cost $600. A boat that's 3 feet long is going to cost $6,000. Make a scatter plot of data. Let X represent length. Let Y represent the cost. And then we're going to find an equation that models the cost depending on the length, and then we're going to use it to predict how much a 20-foot long boat would cost. So our first step needs to be making a scatter plot of the data. So let me take this to some graph paper. Make my X and Y axis. X is the length in feet, and Y is our cost in dollars. Okay, the lengths of the boats go from 11 to 23 feet. I might be able to squeeze it in by ones. Let's try it out. We've got 2 feet. There's 3, 4, 5. There's 6, 7, 8, 9. There's 10. There'd be 12-foot boat, 14, 16, 18. Oh, we can just squeeze it in. That'd be 22, and that'd be 23 right there. Now the costs go from, let's see, it looks like a low value of $500 all the way up to $6,000. So in order to get up to 6,000, let's see, the smaller the scale I use, the more accurate I can be in estimating. I think I'm going to try hundreds. I'll never fit it. 1, 2, 3, 4, 5. Yeah, I'll never fit hundreds. 200s? 200, 400, 600, 800, 1,000. I don't have enough room for 6 of those to get up to 6,000. How about if I go by, let's go by 400s. Let's see if we can fit that. There'd be 400. We'd have 800, 1,600, 2,400. That'd be 3,200. And then, of course, we'd have 36, and then be 4,000. Ooh, are we going to fit this? There's 4,400. Might have to do a little rearranging. There'd be 48, and then we'd have 5,200, 56. Ooh, there we go, 6,000. We fit it in. Something doesn't look right there, does it? Nope. Let's try that again. We're going by 400, so we got 36, 4,000. That'd be 44. This would be 4,800. This would be 52. This would be 5,600. And of course 6,000 would be that top piece. So technology, I can just extend that a little bit. Now let's make our scatter plot. First point was 11,600. So we're 11 over 11 up 600. Let's see, there's 8, there's 4, 600 halfway between. We've got 12,500. 12, there's 400, 500 be about right there. We've got 14, 1,900. Okay, let's see. There's 2,000, a little less than 2,000, 1,900. Close enough. We've got 16, 3,500. There's 3,600, so 35 is a little less than that. 22 feet is $6,500. Let's see, this was 56, this was 6,000, this was 6,400. You got to estimate a little bit here, 6,500, a little above 6,400. There we go. And a 23-foot boat is $6,000 right there on that nice intersection point. We definitely see some positive correlation. It makes sense. The bigger the boat, the more it's going to cost. So if I come up with an equation, let's see, fitted line, it's not too bad. Let's find the slope of that line. Pick 2 points that you can see pretty clearly. I'm going to use this one. That would be 17. And the Y value there is, looks like 3,600. And then maybe I'll use this point here. That is 21. And the Y value is 5,600. Okay, find your slope. Y minus Y over X minus X. We're looking at 2,000 divided by 4. We're looking at a slope of 500. What does that mean in this situation? Every foot longer the boat gets, we can expect the cost to go up about $500. Our equation would be y equals 500x plus our y-intercept. Now shoot, we can't see where this graph crosses the y-axis. Now I can cheat a little bit and use my technology, but I'll show you 2 ways to do it. Okay, if I were to cheat and just extend this, let's find out. Let's see, we got negative 400, negative 8. Oh, this thing's in the way again. Negative 4, 8, 12, 16, 20, 24, 28, 32, 36. There's 40, 44, 48. Oh, I'm going to say that's about 5,000, negative 5,000. But I don't like being sloppy like that. So how could we use our equation and a point we know on the graph to find the y-intercept? It's a good little review. Think of this as an x and a y value. Well, y value is 3,600. When the x value is 17, what's the y-intercept going to be? You get 3,600. 500 times 17 is 8,500. Plus what gives me 3,600. So subtracting 8,500 from both sides, 3,600 minus 8,500, I get negative 4,000 or 900. So our estimate was actually pretty good down here. All right, my full equation, the slope was 500, the y-intercept's negative 4,900. Let's use that. Go back here. Okay, there's our equation and some extra stuff that we don't really need. Okay, we did part A. We made the scatter plot. We found the equation, part B. Now, C, approximate the cost of a 20-foot long sailboat. Put 20 in there for X. 500 times 20 minus 4,900. And we're looking at about $5,100. Answers might vary a little bit, but if your line was decent and your graph was decent, you should have something pretty close to $5,100.